Welcome to the Walton Pi. Today we are going to talk a little bit more about trig functions and their inverses, as well as how to use them in different problems. Let's get started on some trig function stuff. So here are our four quadrants, and let's say we are trying to figure out what is, so there's our angle theta, and we are trying to figure out what is cosine of theta. And let's say that theta is equal to 3 pi over 4 radians. If you're used to this in degrees, the way that you can go back and forth between radians, so if you have 180 over pi times radians, this is going to be the same angle measure in degrees. So 180 over pi times 3 pi over 4, this is going to give us 135 degrees. Again, try and start to think of everything in terms of radians, because that is going to be how we are going to do in this class. So I'm not going to use degrees very often. I am mostly going to be sticking with radians. So if it's 135 degrees, that tells us that this other side is 45 degrees, or pi over 4 radians. Now, this is a very special angle because it allows us to be able to say, well, knowing that this is pi over 4 radians, let's get a better triangle. So knowing that this is pi over 4 radians, that tells us that if we know one side, then we also know this side, and this is going to be the square root of 2 times that side. So, if we are trying to figure out cosine of the angle, well, that's going to be adjacent over hypotenuse. So cosine of theta is going to be adjacent, this x, divided by the square root of 2 times x. So that's going to give us 1 over the square root of 2. Another way to write that is root 2 over 2. However, this is in the second quadrant. It's not in the first quadrant, it's in the second quadrant, which means that this x value is actually negative. So this is going to be negative, negative, and negative. So that tells us that cosine of theta is negative root over 2. And you can do the same thing for any of these other angles. You just have to pay attention to which values are going to be positive or negative x. So using the same theta, let's figure out what is going to be tangent of theta. So what is tangent of 3 pi over 4? Well, tangent is opposite over adjacent, so this is going to be x over negative x, which is going to simplify to be a negative 1. Now, negative 1, if we go back to the graph, that is the slope of this line. That is what tangent means. It's the slope of that line as we go as we go along the hypotenuse. It's the slope of the hypotenuse. And so those are the different things that you might be able to start to pay attention to. Now, something else that we might have to do is we might have to be able to combine the inverse functions. So this is also sometimes written as arc cosine. This is the inverse function of cosine. Now, you might remember that the graph of cosine is doing something like that's 0, and here's our axes. So that's the graph of cosine, which tells us this is not a one-to-one function. The same output comes up more than once. So what we have to do is we have to restrict the domain of cosine to be this interval here, so that it is actually a one-to-one function. We only take those values, and then everything else we kind of have to adjust from there. So on the unit circle, what that means is if this is our unit circle, this is going to be the only region where cosine is going to be, this is the only area where cosine is defined. It is only defined on that section for the inverse cosine. The inverse cosine will always give us an angle somewhere in this region, going all the way up to 0, or all the way up to pi, or all the way down to 0. That's the only region that the inverse cosine is defined. So that is for inverse cosine. However, inverse sine and inverse tangent, those are going to be defined on this region. So if you're trying to think of what intervals you have, for the interval 0 to pi, and then the interval negative pi halves to positive pi halves, so this is going to be inverse cosine, this one's going to be inverse sine, and then inverse tangent is the same as inverse sine, except it does not include the endpoints. So those are going to be where the outputs of inverse cosine, inverse sine, and inverse tangent will be. So let's go and do some problems involving these. Alright, so let's go through and figure out how we might be able to use these inverse functions in certain problems. So let's say we are looking at tangent of inverse cosine of x. Well, inverse cosine, that takes a ratio and gives us out an angle. So let's say that this is our angle theta, so that cosine inverse of x, so the inverse cosine of x is equal to theta. That tells us that x is equal to cosine of theta. Well, cosine is adjacent over hypotenuse, so that tells us that adjacent over hypotenuse is equal to x. So we just need to put some values on the sides of this triangle so that adjacent over hypotenuse is equal to x. Well, one of the easiest things to do is to make the thing that it's over equal to 1. So that tells us that adjacent would be x. The next thing we might need to do is we might need to figure out, well, what is our opposite side? Fortunately, we know that this is going to be a right triangle. So if this side is like our opposite, that tells us that x squared plus the opposite squared has to be equal to 1. So opposite squared is equal to 1 minus x squared. So opposite is going to be equal to the square root of 1 minus x squared. Well, we know that inverse cosine of x is that angle, so we get tangent of that angle theta. Well, that's going to be equal to opposite over adjacent. And we just figured out our opposite was the square root of 1 minus x squared. So that's all going to be, and then adjacent was x. So this is tangent of inverse cosine of x. And we can do this for all sorts of different problems. So let's say that we are trying to figure out what is sine of inverse tangent of x. Well, draw the triangle, have your angle theta. Tangent is opposite over adjacent. And so that tells us that we want this to be equal to x over 1. This side is x, this side is 1. That tells us the hypotenuse is going to be the square root of 1 plus x squared. Well, we are now looking at sine of theta. Sine is opposite over hypotenuse, so this is going to be equal to opposite x over hypotenuse square root of 1 plus x squared. So these are how we can be able to combine these different functions in different ways. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.